I've always had this dream of living in a natural home built by myself and surrounded by those closest to me. Although it seems the barrier to entry for self-building a natural home is pretty high. For example, I was unable to find a single video which summarizes the process of building a natural home from a regulatory point of view, and because of this I've decided to create one. In this video I will outline all building regulations which need to be adhered to in the UK, highlight those regulations specifically challenging to pass for natural homes, and suggest ways to overcome those tricky regulations. I'll also provide some further advice for how to make sure your planning permission gets granted. And whilst this video does detail requirements specific to building in England, requirements in other regions will likely be similar, so it could still be worth tuning in, even if it is just food for thought. Regulations for building in the UK are described in the Building Regulations Merged Approved documents. The information shared in this video includes changes made from June 2022 and is up to date as of March 2023. I want to disclaim that what I am presenting in this video is my interpretation of the regulations. I see this video as providing a good basis of understanding, and I think a basis of understanding is so important to ensure that someone doesn't take you for a ride. For example, an engineering consultancy. I'm now going to succinctly summarize the 17 overarching requirements for building any home, then as stated I will hone into those which are specifically challenging for natural homes. Part A covers structure and details requirements for safe loading, foundation stability, and measures to reduce sensitivity of a disproportionate collapse. Part B states fire safety requirements, an example of which is a method to inhibit the spread of fire. Part C provides guidance on site preparation, i.e. foundations, and resistance to contaminants and moisture. An example of one such guidance is to ensure ground moisture does not negatively impact the integrity of the foundation. Part D controls the use of toxic substances as cavity wall insulation. In other words, it states which insulation materials can and cannot be used. Part E provides guidance on resistance to the passage of sound. Part F describes ventilation requirements, an example being that purge ventilation, which I didn't know meant windows, are required in each habitable room. Interestingly, there are also minimum opening area requirements for windows, which I also didn't know about. Part G explores sanitation, hot water safety, and water efficiency. And this part describes requirements surrounding water, which can be repurposed, for example, for toilet flushing. Part H relates to drainage and waste. One example is requirements for where foul water can be drained. Part J is all about combustion appliances and fuel storage systems. Amongst other motives, this set of requirements ensures products of combustion are discharged outside and the house has a safe level of pollutants. Part K is about preventative guidance for protection from falling, collision, and impact. One way this is done is by recommending specific stair geometries. Part ADL1 relates to the fuel and power and how to comply with energy efficiency requirements. This is typically regarded as the most difficult requirement to meet for natural homes, as some natural building materials can be relatively bad insulators. Part M details requirements which ensure the building is accessible, for example by road. Part O aims to protect the welfare of occupants by reducing the occurrence of high indoor temperatures. For natural homes, there are a lot of really interesting ways this can be met, as I will explore in the next section. Part P relates to electrical safety and is in place to make sure sufficient information is available if anyone needs to alter an electrical installation with reasonable safety. Examples of required information is electrical installation certificates, operating instructions, and labels where suitable. There is even guidance for wall socket heights, which is to make sure they are between 450mm and 1200mm above floor level. Part Q discusses unauthorized access mitigation and details how easily accessible doors and windows need to meet security requirements. Some quantitative examples of those requirements are that the door set should be manufactured from solid or laminated timber with a minimum density of 600 kilograms per meter cubed, and door set panels should be at least 15mm thick. Part R is the requirement to provide in-building physical infrastructure so that in the future, fiber optic cables or wireless devices capable of delivering broadband speeds greater than 30 megabytes per second can be installed. Note the building doesn't actually need to have the fiber optic cables or wireless devices installed, and there are actually a fair few exceptions to this requirement, as I will discuss in the next section. Part S, the final part, provides guidance on the installation and location of infrastructure for charging electric vehicles. Although a fair few of those requirements won't actually change if a home is constructed using natural building materials or using traditional building materials, such as bricks. Next up, I'm going to discuss the requirements which I think are most individual to natural homes and discuss how those requirements can be met. So for part A, at first I was a bit concerned about designing a natural home to meet seismic design specifications. However, if you do live in England, it has a negligible risk of instability or ground movements, and a natural home will most of the time be classified as a Class 1 building. Class 1 buildings automatically meet A3 requirements if A1 and A2 are met. There is also a required minimum compressive strength for the wall, so I thought this could also be challenging depending on the materials which you choose to use to construct your natural home. If I were to build a natural home, the story height would be less than 2.7 meters, and therefore these walls would fall under condition A, and the normalized compressive strength of clay and calcium silicate blocks would be 5 newtons per millimeter squared for those with less than 25% formed voids. However, natural building materials can have relatively low compressive strengths. For example, cob can have compressive strengths of 1 to 2 newtons per millimeter squared. However, considering normal wall stresses are 0.1 to 0.2 newtons per millimeter squared, cob walls can provide a safe, viable load-bearing wall construction. And a simple way to measure compressive strength of a building material is to sandwich the building material between two plates which are parallel to each other, and then to apply a measured force to those plates. When the material breaks, the compressive strength can be determined by dividing the force at breakage by the cross-sectional area of the test material sample. Conditions for determining general wall thickness is no different to a normal home, such that it should be at least 1.33 times 1/16 of the story height. However, as we will explore later, that wall thickness might not be enough to meet the thermal transmittance requirement. General dimensions shouldn't be any more challenging to achieve for a natural home compared with a traditional brick or mortar building. On top of that, there is nothing stated in Part A which would make adhering to the foundation, cladding or roof design requirements any more difficult for a natural home than a traditional brick or mortar building. Part C requires that a natural home building site is investigated for susceptibility to groundwater levels and flow, geology and hydrogeological properties. In short, this is to identify any hazards such as roots which could affect foundations if they were to grow, and to provide appropriate soil parameters for design and construction. Determining soil parameters is necessary for design as different soils will be subject to different changes in volume when a load is applied. The site might also contain contaminants. Sites which were used agriculturally may be contaminated by pesticides, fertilizer, or decaying biological matter. Assessing the risks for land contamination is necessary in line with the British Standards Code of Practice for Site Investigations and Code of Practice for Investigation of Potentially Contaminated Sites. Risk assessments for land development of land affected by contaminants should consider the health and safety of the public and workers. One of the most careful considerations should be made to ensure explosive gases, for example methane, and radioactive gases, for example radon, have not contaminated the site. However, a wide range of treatment processes are available for dealing with different contaminants if they are present. The site should also not be susceptible to flooding. If in flood zone 2 or 3, a flood risk assessment will need to be conducted, and appropriate steps must be taken to mitigate the probability of flooding. For example, afforestation is a brilliant way to mitigate flooding, as it increases interception and storage of water, whilst also reducing the amount of surface runoff. So for most homes, any internal or external wall will meet the requirement if a damp-proof course is provided. The technical solution actually states that a damp-proof course or any other material that will prevent the passage of moisture will suffice. A solid wall will meet the requirement if it will hold moisture arising from rain and snow until it can be released in a dry period without penetrating to the inside of the building or without causing any damage to the building. The wall thickness will depend on the severity of wind-driven rain. Applying a damp-proof membrane and a masonry base between the underside of the natural building materials and the top of the foundations can mitigate this issue. And as the function of damp-proof course is to prevent water from wicking up through the footings of the building into the walls, good perimeter draining, i.e. draining water away from the building's footings, should be an effective mitigation strategy. And whilst constant heating is another suggestion I found online, you might not want nor have the resources to heat a house all day in the winter. Part G states that there must be suitable installation for the provision of wholesome water, which is of a suitable quality. Wholesome water is provided by a statutory water undertaker, a licensed water supplier, or a source complying with the Private Water Supplies Regulation 2009. However, water treated to the high standard of wholesome water is not essential for all uses of water in buildings. For example, toilet flushing, as I mentioned earlier. Alternative sources of water could be used through wells, harvested rainwater, or reclaimed grey water. For a natural home, you're probably going to want to use a well/harvest rainwater as your main water sources. Firstly, you might not even be able to extract the desired amount of water from a well. You would need the site to be surveyed and a hydrogeological map of the area to be produced before you can know that. And for domestic needs, you will almost definitely be extracting less than 20 meters cubed per day, so you shouldn't need to worry about getting an abstracting license for that. Secondly, with either a well or harvested rainwater system, you will still need to ensure water is filtered and meets the Private Water Supplies Regulation 2009 as suggested above. I wanted to highlight that for the hot water supply, solar water heating is possible. However, where solar water heating systems are used, an additional heat source should be available to ensure temperature is maintained and microbial growth is restricted. Ideally, rainwater would be input into that hot water tank, but if not possible, rainwater should be stored in a tank situated in the shade and should be regularly cleared of organic debris to discourage bacteria growth. Sanitary conveniences shouldn't differ for brick or mortar homes and natural homes, although once again I do think it's important to note that for composting toilets that you might be more inclined to use in a natural home, there are currently no British or European standards. However, guidance is that suitable arrangements are made to dispose of waste without carrying it through any living space or food preparation area. If you're looking for help in determining your water consumption, Part G also has a really useful reference for values which you can use, and that can help you decipher which water source might be most suited to you. Part H outlines where foul water should be drained and is relatively flexible, such that whilst a public sewer is the ideal output, a private sewer or septic tank is also acceptable. However, the drainage of foul water does not apply to the diversion of water. So if your natural home will divert water, for example to growing plants, my understanding is that this requirement will not apply. Part H also advises on safe construction where there may be other sewers, such that construction is not detrimental to nearby buildings. However, providing you a building on a fresh plot of land, this shouldn't be an issue, as there would actually be no nearby building sewer systems to damage. Part ADL1 provides guidance on how to meet minimum energy performance requirements for new buildings. This involves consideration into carbon dioxide emission rates, fabric efficiency rates, and primary energy rates. Most discussed and probably most specific to natural homes is the minimum energy performance requirement for building materials, such that they don't transmit and lose too much heat. A U value is a measure of heat transmission through a building part, and they generally range from 0.1, which is very little heat loss, to 1, which is lots of heat loss. U values should be assessed using methods and conventions set out in the Building Research Establishment's BR 443. As alluded to earlier, meeting thermal transmittance requirements are often the most challenging for natural homes. Interestingly, Part ADL1 appears to contradict Part C, which mentioned walls and roofs should not at any point exceed 0.7 and 0.35 watts per meters squared Kelvin, respectively. Contrastingly, part ADL1 states walls and roofs should not exceed 0.26 and 0.16 watts per meter squared Kelvin, respectively. My understanding that this is ahead of even more stringent decreases in 2025. So building a house using only natural materials is likely to get even more difficult. For a natural home, the only real time a building would be exempt from Part L would be if the building is in a conservation area where compliance with energy efficiency requirements would unacceptably alter character or appearance. Although that then becomes a chicken or the egg situation, as you wouldn't actually be able to get planning permission to build in a conservation area. Adding an air gap, which is also called a cavity, between walls is a good way of reducing the U value of walls. A way to reduce the U value even further is by adding insulation into that air gap. A pretty interesting natural and sustainable insulation is hemp shift, which I allude to in my video on cob housing. For Part M, 2 of the 3 requirements stated in the building regulation document are defined as optional requirements, which means the only requirement which needs to be adhered to is the one that states that reasonable permission should be made for people to gain access to and use the dwelling and its facility. Some examples of how this could be achieved is by making it possible to gain access to the dwelling from a road and by ensuring facilities can be used by people of varying ages and disabilities. I thought this to be relevant considering a lot of natural homes are likely to be in pretty remote areas. Part O states that reasonable provision should be made to limit unwanted solar gains in the summer and to provide an adequate means to remove heat from the indoor environment. But how can this be achieved? So demonstrating compliance can differ based on if your area is a high or moderate risk and if your building has cross ventilation and the quantity of glazing your windows have. Although acceptable strategies include shutters, blinds and overhangs, which are all pretty easy to install even after your natural home is built. I have also seen quite a few earth chips experiment with the actual tilt of the glass to retain more solar energy. Part R outlines the need for infrastructure to install network cables, which to me seems like one of those hidden rules that, had I not reviewed the regulations, I absolutely wouldn't know. As I alluded to earlier, what makes Part R easier to meet is that there is no requirement to actually install the fibre optic cables or the wireless devices themselves. Additionally, for the case of natural homes, they could be exempt if the building is in an isolated area where the prospect of high-speed connection is considered too remote to justify equipping the building with high-speed ready in-building physical infrastructure or an access point, or if the character appearance would be unacceptably altered, such as in conservation areas, or if the building has no sleeping accommodation. Obviously, if you're using it as a house, that's not going to work because you need to sleep somewhere. So on to the last section now, further advice for getting planning permission granted. From what I understand, your local authority has a fair chunk of power when it comes to approving or disproving your planning permission application. The Self-Build and Custom House Building Regulations 2016 state that pieces of land to be possible for development, as decided by the local authority, will need to meet national and local planning policy. Neighbourhood development plans can be a really good way to understand the local planning policy, and this is because once a neighbourhood plan is made, it actually forms the basis for determining planning application in that area. Your self-build will need to align with strategic objectives for the county where you live. For example, one of those objectives for the area where I live is ensuring high quality development which contributes to and reinforces landscape character. This involves conserving and enhancing semi-natural habitats, minimizing the impact of lighting and protecting area of tranquil character from visually intrusive or noisy development. In fact, it's actually stated that my local authority allows for small-scale incremental development in the countryside and in rural settlements as a means of supporting the economic and social health of the countryside. An eligibility condition which I found particularly interesting was that an individual who applies for planning permission should have sufficient connection with the local authority area. And whilst that does make sense, it just isn't something that I thought about before. As noted at the start of the video, this video is to provide a basis of knowledge for regulations to build a natural home in England. and the type of considerations you need to make before having planning permission granted for a natural self-build. I really hope you enjoyed the video and would be interested to hear any of your thoughts and questions in the comment section below.